All right, so in lesson 2.6, we're going to talk about how to use similarity to find other parts of either similar figures or even the areas of those similar figures. The first couple sections here are not actually on your worksheet, so you want to turn that over. We're going to take some notes here first. Taking a look here, we have similar figures, and the similar figures, the sides are shown. I'm telling you they're similar. We just have to create the ratio for that. So the ratio for that would be taking any of the corresponding sides. In this case, we'll just take 18 and 12, and then 12 and 8, and we'll make that fraction. At the same time, we're also going to calculate the perimeters of each. So you're going to add up all the sides for each of them, and we're also going to calculate those. All the while, you still see the similar figures. The ratios are 18 to 12, 12 to 8, 42 to 28, and ultimately everything simplifies to the fraction 3/2 or 3 to 2. So the point here is that anytime you can find the ratio between two figures, in this case 18 to 12, or even this case 18 to this 12, is similar to this 12 to this 8, and every single time the perimeter will have the same exact ratio as the figure itself to the similar one. Now, in the next instance, it's asking us for number 1 to find the ratio of the perimeters and also the areas. You'll notice that it gives you the rectangle and only one side is given. So let's say 9 and 5 in this case for number 1. In the previous slide, we show that the ratio of the figure equals the ratio of the perimeters. However, this one's asking you to find the areas. So the ratio of the areas actually equals the ratio of the perimeters squared. And we're going to explore that in just a second. So on the back side of your worksheet, we're going to make a little chart here. Instead of making it 9 and 5, I chose to make it 10 and 5 so you could see it a little easier. I chose two sides, 4 and 2, to keep the ratio the same. So the ratio of side 1 would be 10 to 5. The ratio of side 2 would be 4 to 2. Their perimeters are both 28 and 14, and everything simplifies to the same ratio, 2 over 1. So the ratio of figure A to figure B is 2 to 1. The ratio of their perimeters is 2 to 1, and every side's ratio is also 2 to 1. Now, let's take the length times width formula and multiply 10 times 4. The ratio of figure A, the area of figure A is 40. The area of figure B, 5 times 2 is 10. So the ratio of their areas is 4 to 1. So actually, if you take the ratio of their perimeters, 2 over 1, and square it, 2 squared is 4, 1 squared is 1, and you get the ratio of their areas to be the square of their perimeters. All right, just to make it a little simpler for you, I took a square here. And the square has labels of 3 and 1. Obviously, squares are always similar because their sides are always the same length. So if the figure's ratio is 3 to 1, both sides are 3 to 1. If the perimeters are both 3 to 1, for instance, 3 times 4 is 12. 12 to 4 would be 3 to 1. The ratio of their areas is simply taking the ratio that we had and squaring it. 3 squared is 9. 1 squared is 1. The area of the larger figure is 9. The area of the smaller figure is 1. And so their ratio is 9 to 1 in comparison to the ratio of the figure and their perimeters. Take a second, answer questions 1, 2, and 3. Hopefully this last slide will help you answer those questions. Hit pause and do that now. Okay, you should be able to answer questions 4A and B as they're just similar to the ones you just answered. However, in question C for number 4, it brings up a different point that we're going to walk through together. The given information is that ratio of two rectangles is 4 to 5. And it asks you to find the perimeter of the smaller table based on the larger one. So in this case, the first question I have to ask you is, which one is the larger one? Based on the ratio of 4 to 5, which one would represent the larger of the two? In this case, the larger of the two is the one, whatever side or whatever table is linked to the number 5. Obviously, 5 is larger than 4. So if that were the case, could you use the table length of 44 feet and create the corresponding side to 5, only that you're going to solve for the missing part and solve that for x. So could you create that proportion? The proportion would be found by doing 4 to 5, just as the ratio says, and the 44 is obviously linked to the 5, as I explained above. Since we don't know the length or the perimeter of the smaller rectangle, we're going to set that equal to x. From here, we're simply going to cross multiply and solve. Take a second and solve for x. Hopefully, after you solve for x, you found that x equaled 35.2 feet. That gives you the answer for the perimeter of the smaller of the two rectangular tables. Hopefully this helps you answer questions 5 and 6. Please bring any questions along with the worksheet back to class on Monday.